Hello, everybody. I'm uploading my set of lecture slides. It's still happening, so I'll give me a few more minutes for the lecture to be uploaded. Thanks. All right. Good afternoon, everybody. I'm Saman Disila here from Australia. How are you today? Hope you all are doing well. We have 87 students taking part, so I think um, thanks, man. Uh, Thank you. Um, so we have about 80 odd students joining in. Thank you everyone for coming on time. I think my PowerPoint slides are now all uploaded. So what I'm going to do is take you through this particular subject area and mostly the key points, especially discussing about the leading up to your project work more so. And tomorrow we will have our workshops. The way that I have set it up in the canvas, we will have tomorrow morning session for those who are designing type A and type B units, so that I can work with you and help you through um, like design workshop, uh, how to do the interior planning. Some of you may have already done it, so you can actually compare and improve what you were thinking about how to use do the interior planning. And also I will probably go with you the framing of your flow, helping you out how you can actually develop a framing plan, and then you can of course design it using your design codes and so forth. So the idea is today I will go through like a lecture. You can raise your hand and ask a question, or you can type a question and send to me. I will go through them and probably ready for tomorrow answer immediately, or otherwise I can send you a reply, summarize it, and then send you a reply as well. So this particular subject, I'm not sure. This may be the first project that uh, yeah, I will after this lecture I will upload these files to canvas. I haven't uploaded this one to canvas as yet, but hope that you can see on your screen. Is that correct? Can you all see the slides on your screen? Yeah. Yeah. Okay. Thank you. Thank you very much. I will, as soon as I finish it, I will upload it to Canvas. That's no problem. So we'll start. Basically, I wanted to explain this particular subject slightly little differently than the normal subjects. This is called project-based learning mode. What does that really mean? Is that you will do a major project, and then by doing it you will learn what is expected to be learned. So it is like you're doing a major design task. Some of you may be fresh students, some of you all have are from the industry. Those who are from industry maybe um, may find it much applicable, and then the students who are coming uh, as a full-time students, um, this will be probably a major project task that you would undertake. So the idea here is to guys do a comprehensive design project and then try to learn a few elements of what we call sustainable building designs or sustainable or green building design aspects. So some of the discussions today are a little bit prescriptive, and then content is more written type, not a lot of mathematics involved in at the moment. Um, and when we explain the project to you, and then hopefully you will see where your uh, knowledge in concrete design and other things will come into play. This course assumes that you have already done your uh, uh, reinforced concrete design. There is a certain part we call structural design part, and the other part is actually we are trying to find how creative you are as a designer, and then how you can actually do it. So little bit it is different from like purely doing a beam design using reinforced concrete or steel, but it involves little bit of thinking as a designer. Um, so it is not necessarily a mathematical way of design or just referring to a code and doing some numbers, but it is more involved in how we normally do this in practice. So let's go um, to define what we call engineering green building fundamentals. Simply speaking, guys, if you look at when I was an sort of engineering student a long time back, um, we mainly focus about designing a building. We never worried about the sustainability. We were not taught to worry about it much. We always look for the most cost-effective solution, and also from a structural design point of view, we were taught how to design beams and slabs and columns and walls and things like that. But nowadays it is totally different. Nowadays, of course, our design aspect remains the same, but we are expected to be mindful of um, when your project is finished that some of the green fundamentals are being included in the work that you do. So let's look at these green fundamentals, what it means. Uh, One is the first things that whether it is a normal building, commercial building, or an office building, or residential tower, particularly in Hong Kong, you know there are many high-rise residential buildings. So these residential buildings can be designed in such a way that your cooling and heating can be minimized. I know in Hong Kong you will be using air conditioners for cooling most of the time. Heating is very rarely you have to do heating in Hong Kong. But other parts of the world, like say for an example, northern part of Europe or even in Melbourne, where I live, uh, we need heating. Uh, more than cooling. Cooling is summer period, yes, sometimes occasionally, but during winter we have to have our houses heated up all the time. So the the fun sustainable design, in particularly building design, involves how to harness, which means use the solar energy, not like you putting solar panels on the roof. That is also one way, but apart from that, you can actually design your building in such a way you, in a cold seasons, you will have more light inside your house, and then during winter that you will have during summer, that you can you try to keep the heat from sun away from your living spaces. So that is kind of trading between solar energy, which is naturally available, freely available solar energy from the sun inside your house, um, and then during invite it inside the house during cold periods, and then keep it out when during the warmer period. So there is set of principles that we can use to do that. That is called passive design principles. So it is much more useful in colder part of your continent and in Australia, but in the warm period also it is useful. But still we may need a little bit of cooling, um, mechanical cooling. The other thing which is very getting interested in what we call the embodied energy of the materials, which means very energy intensive materials are now slowly phasing out. It is people are not happy to use them, so uh, we are now moving into a lot of new materials which have very little embodied energy in them. I will explain to you what is embodied energy really means. There are two types of energy which we use in any house or any building. One is called the operational energy, that you know very well. That is the electricity you use for your lighting, your fans, and your cooling systems and things like that. That is operational energy. But what you call the embodied energy is the materials which are the amount of energy which is required to produce those materials, and then that is embedded in the material itself. For an example, to we can identify how much of energy would require to in terms of gigajoules, how much of energy would require to produce 1 cubic meter of concrete, for an example. For tiles, for bricks, for blockwork, for steel members, you can now quantify how much of embodied energy. This embodied energy means what is there already. It is nothing to do with how we use the energy, but it is the energy which is required for the materials to be in place. Of course, operational energy reduction can be done using solar energy, or as I said, using passive design principles and so forth. And then the other part of sustainability, as you all know, the water saving, especially the potable water here. The word potable water means that drinkable water, a water which is purified, which is good enough for us to drink. So these are called potable water. So what we do normally is used to do was that we refine this water as much as we possibly can, but then we use those such water to wash your driveways, roads, and things like that. So nowadays, there's a big um, need to try and minimize the wasting of the potable water, because it costs a lot. And the other thing which we try to do in most of the countries is try to harness rainwater as best as we can, and also treat grey water recycling. Now, of course, we use the grey water recycling was a common practice everywhere, but now we are trying to do it even on site, say house by house, we are trying to do it. It's very similar to in a single houses, we put solar energy, solar cells, and then use the solar energy for our purpose. Very similarly, now in some cases that we have some developments and estates which they would use their own grey water, recycled on site, and then they can reuse it. It cannot be good, it cannot be used, of course, for drinking purposes. Drinking, you will still have potable water supply, but what that does is that you can use it for toilet flushing, using the toilets and things like that, which we'll discuss a little bit later. So the green building fundamentals involve a lot of uh, thinking and practices. Um, the other thing is, which is very less involved in civil engineering per se, but if you are a building designer, particularly you're working with an architect, for an example, um, you will find that the indoor environmental air quality is a very important thing, particularly if you consider the current situation. If you were to stay in the house all day inside, you will see that the indoor environment air quality is a very important aspect of it. If you look at most of the cities nowadays, because of the dust pollution and things like that, internal air quality is also becoming a very important factor in building design. The other, in overall, what we are trying to do here is simply neutralize the carbon footprint by doing all these energy saving, minimizing embodied energy intensive materials, and then getting the material which are much easier, much less energy intensive material, and then more importantly, uh, you also neutralize carbon footprint in your design by, say, for an example, in large developments, particularly in Hong Kong, they are doing it this very seriously now. For an example, if you look at your residential um, towers, which is the housing authority of Hong Kong, what they do is if they have a tall building which is for residential purposes, they make sure that the tree plantation and greening of the building is done to kind of minimize the carbon footprint of your building. So that is the practice that is going to be there. So in a general sense, that's what it is. If you therefore, if we are purely focusing on the water saving, energy saving has to be identified first as I already said, embodied energy, operational energy. And you also have what we call in any house or any building, what we call recurring energy, which means that some during the lifespan of the structure, you have to maintain that structure. You have to do some improvements. You will be repainting it. You may be replacing your carpets and tiles and things like that. So any improvement um, will have some energy. So when we are estimating the energy consumed within a building, you have three parts to take into consideration. There are a lot of software nowadays available which will do all this for you easily, but important thing is that embodied energy, which is the energy which is already inside the building material, which not only structural material, it is to do with the finishes. Say for an example, how much energy would require to have, say, 100 tiles, floor tiles, what sort of energy is embedded in that production. If you look at services, say plumbing, electricity, gas, all services, which are the pipelines and everything to go with it. How much of embodied energy in this? Every good that you use inside the house or in your building would involve this embodied energy component. But it is not a variable; it is fixed amount inside your house once it is built. Operational energy is increasing over the period of time. So if you have a 50-year period, if you're consuming X amount of energy with it per year, of course you can calculate how much would it for its lifespan, considering it is a 50-year lifespan. So that is important. There is operational energies used for broadly heating, which is the thermal comfort, cooking and cleaning, water heating, lighting, lifestyle needs, entertainment, communication, and things like that. And then the other thing is called vertical transportation, which is very relevant to Hong Kong in tall residential towers, that your lifts are acting like a vertical transportation from one floor to the other. Those energy has to come together as well. So that is, all this is therefore coming as the energy consumption aspect of it. There are a lot of, I don't want you to be too much worried about this one, but there are a number of different ways that you calculate your embodied energy of materials. And then uh, also divided into two parts. There are the specialized people who would be estimating these values, and then put in all the green building assessment tools so that it can be calculated by others. But broadly speaking, there are two types of energies we are talking about embodied energy. One is called cradle to gate, which means that the from beginning and starting point of that material processing up to the delivery point, from the delivery point, which is the factory. The classic example is, say for an example, if you have your windows are glasses, and then you can identify when that particular product leaves the production line, how much of energy embedded in that one. It is called cradle. Cradle here is like your birthplace to the gate. And then the next component in building industry is that you get these materials, and then you had to put it in place, you had to fix it on site, and then you had to transport it, and then you need tradespeople to transport it, and then that part is called cradle to site. So there are two components. Don't worry about it. This is not necessarily we are calculating it or identifying it by ourselves. There are specialists who are doing that, but we indeed need to know that in most of the green building tools, that this is part of that tool database, so that will enable you to work the embodied energy component. I wanted to just show the embodied energy part as two components, because especially in the construction process, on-site amount of embodied energy goes into the building on-site is relatively significant as well, which is a reasonable number. This one is from our data here in single dwellings in Australia. As you know, unlike Hong Kong, here where most of the residential buildings are small apartments, flats, and mostly single dwelling, individual plots, single story or two-story houses. But in the cities, we have a few high density residential buildings, but those are not comparable to the number of residential towers Hong Kong has. So in your case, slightly these figures are different, but what is important is to understand is this is just a graph showing each and every element, how much of energy as a percentage of the total energy that we use in a building. Now, obviously, why this type of chart is very important. You can see straight away external walls, in the way that Australians are constructing this. What we have is like the burn bricks being used as the external wall. So there are a large amount of kiln dried bricks which we are using, and then those type of buildings have enormous amount of energy in the bricks itself. You can see the internal walls, which is plasterboard. Roof is not that much because we are using cement tiles, for an example, not rather than clay tiles. So all the other values are fairly okay, but external walls are consuming a lot of for the insulation, and particularly if we use bricks. So this is one of the areas actually Australia has worked over the last 10 years. If you look at brick industry, brick producing industry has completely changed their way of producing bricks, because otherwise they had to pay huge amount of taxes, carbon taxes, if they don't improve their product. One of the good thing about this type of measurements is the measurement shows, not in a bad way, but in a good way, that industry can look at it, and then the industry can improve by itself. So that is a very important step towards the sustainable construction, because every industry tries to then minimize the production energy amount, which is the embodied energy amount in their product. Then all of a sudden you can see that the industry will become a very good practice, because uh, you're not, nobody can say, oh, you have to reduce this much, but you can show to the industry through researchers that if can you try and improve this production, method of production, so that your energy consumption is much less. Therefore, that helps the process. So that's the reason I have put this particular graph for you to get an understanding. Two things. One, actually now we can quantify almost all the parts involved in construction industry, how much of energy they consume to produce those things. This include the facades, this can include the concrete industry, this can include uh, uh, window manufacturers, this can include painting, this can include the finishers, and all that can be now reasonably measured. This is not a perfected science, but that this is can definitely give the relative positioning of different elements of the construction industry. When you do that, the construction industry will try and improve their way of doing things. So that's the idea here. Uh, I'll show you this very simple thing, which I find very interesting. If you go to a supermarket, you will see that you have a apple or oranges or whatever. They are natural products, right? They have negative carbon footprint, actually speaking. Now we stick these two little stickers. You may think, oh my God, are you going to that level? That is not what I'm saying here. So these two stickers we have unnecessarily add a carbon footprint into this product for no reason. For promotional reason, maybe for advertising, maybe, but there's no other need for these two stickers to be there. We know apple is apple, we know orange is orange, so why should we do it? And this practice was there before. Now this practice is no longer there. Why? Because the researchers has pointed this out, and then some of the industries realize, yes, of course. Now this is a very small example, and just think about the packaging. Just think about all the other things coming into play. So when you're talking about sustainability, is a big picture ideas. It is the awareness of little things you can do, and then by doing that, you're improving your process. Now you may be wondering, oh, what is this to do with the engineers? Of course, engineers are the people who can really uh, bring this to the knowledge, and then also quantify these amounts, and then try and see, okay, why don't we be a little bit careful and then conscious about what we do. I'll give you another small exercise which we developed. I personally involved in this research project. Uh, most of the structural, any activity, engineering activity, you would know, um, you will be completing what we call the bill of quantities. You may have, if you are work in the industry, or if you have done your building estimations, we know what we used to do is we used to have the component, let's say a flow, windows, or whatever you like to call it, and then there is a specification of that. And then unit can be measured by the meter squares or linear meters. And then you go the quantity, and then you can exactly calculate the cost. Now, if you look at these columns, um, up to here is the general practice. The practice which we used to have, which we never have this particular part in that. So now there are tools which is suggesting we should not only calculate the cost of a building, we had also estimate the amount of energy consumption which can be directly related to the carbon emission, and then that should be recorded. This is still not law. Nobody's legally don't have to do it. But the ideas of green building also means that researchers might come and say this type of tools. Now, the good thing about this is, say for an example, we are not going to punish anybody. What we are trying to say here is, if you know this figure, you yourself, or the civil engineering industry, building industry can say, hey, hang on a second. You can see here the clay bricks was about 110 millimeter thick. He's having 374 some gigajoules in that. Can we reduce these items embodied energy by other technologies without putting it to an oven and burn it? Can we find a way that we replace burnt, which I call the kiln burnt bridges, which means that they put into a furnace and then heat it up until it dries out. So can we replace that with other products? So that is how the Hebel bricks are coming. Now cemented bricks are coming, like Hebel walls, a classic product, which doesn't have a similar footprint. So these are very interesting points. So this was done simply like a research project, but we could show that the total cost of your house construction, in this case 205,000, and the total embodied energy was 1,312 gigajoules. So that can be directly related to the carbon emission, and then by doing that, we can encourage people to improve their production. So these are new ideas and new trends in the industry. So we like our third year students to know the big picture ideas. We as designers can design a building. It is not a big problem, but we also need to be a little bit fully aware of the big picture scenario as far as the sustainability is concerned. So that is why bill of embodied energy can be generated in most of the cases, can be directly then related to the number of tons of carbon dioxide emissions in a particular sector, which in here it is building sector. So operational energy efficiency is the next one. So we were talking about the energy consumption, which is directly relevant to the carbon emission and carbon footprint. Now what we're talking here is the part of the operation energy being discussed. Sorry, embodied energy being discussed. And the next part is, of course, the operational energy. Unfortunately, I was to show you a graph. The graph has been come here, but it is not the way that it should come, but I will explain to you. So the achieving operational energy efficiency, obviously, we have to look for minimize the burning of fossil fuel, try and use the solar energy if possible. The other one is design according to the passive design principles, which can save, we know about 20% of the heating and cooling energy which is required to a building over a period of time. And then the thermal insulation and higher energy rating ceilings, which means if you are in a colder environment, this is much more number three. Item number three is more for colder countries. Probably Hong Kong is slightly not in that category, but from Hong Kong perspective, it is the cooling energy which is going to be the case. So even in that case, your thermal insulation must be really good. Otherwise, you will keep on cooling it, but it will lose that if your insulation outside the building is not proper. So nowadays, heating or cooling savings, you normally use double glazed windows. In Australia, this is almost mandatory now. You cannot do single glazed windows, but I don't think Hong Kong has that rule. This is mainly because, particularly in Victoria, we have the winters which is reasonably cold. The other one is energy efficient appliances that it's a long time ago. We never had this star rating in our appliances. Now every appliance will have certain star rating from energy point of view. So it is it is taken into consideration. It takes a long time to take this one on board, but it is now very serious. People are thinking very seriously on these sustainable aspects of it. The other one is you can do all these things, but if the commitment by the energy user, which means if I don't switch off my lights when that is not necessary, if I'm not safe, if I'm not careful about my energy usage, then of course all the hard work is will be pointless. But that is something we cannot control. For that, of course, now we have sensor systems which we know automatically switch off the lights if the movement is not there. We have louvers and drapes, which is like the curtains which close and opens using the sensors when the light is high and low. We have types of windows which works as your pair of sunglasses, and those sunglasses can vary its intensity of coverage. So there are a lot of products now coming into play, replacing the user if the user is not very smart in energy saving, but the appliances will do it for you, kind of situation. That's an interesting development as well. Sorry guys, this is the graph which didn't come up very well at all, but when I put the PowerPoint slide, you will see it doesn't come in the screen share for whatever the reason, but when I put this PowerPoint slides, you will probably have that. Basically meaning all these three lines here are energy users. The red line is the heavy users, medium users, and the low end users of energy. The different people have different situations in your buildings. The y-axis here was the gigajoules energy consumption. The horizontal axis, which you can't see here, is the number of years. So over a 50 year, if you look at you can see this is the operational energy of a typical building in Australian condition. I'm pretty sure this type of curves must be there in Hong Kong as well. But then if the embodied energy line, if I draw an embodied energy line, that particular embodied energy line would be, I use a different color for an example. Use purple or something. It would be hopefully go like that. Why? It is almost a constant. So this one here is the vertical axis, which is basically the energy in gigajoules, and this is the x-axis, which is basically the number of years. So starting from this at 0 means that is when you occupy your house. By the time you occupy your house, you can see the embodied energy will never change. Quite frankly, correctly speaking, I should have done like that, right? I should have done a little bit like that. That is the recurrence energy. If you have, say, for an example, repairs and things like that, embodied energy will keep on adding to the original one, little steps, but it is not as steep as this. But what you can see is, guys, here in Australian condition, if I draw a line here, about this is about 25 years point. So embodied energy of a house is about 25%, 25 years equivalence of the operational energy. So that is a fairly a big amount. Of course, it doesn't increase over the lifespan of the structure because it is at the beginning. It is the construction period that this goes. Operational energy is when you go inside the building, when you start using the building. So obviously, actually speaking, the real energy, if you wanted to find out real energy of a residential building, what you need to do is you have to add, let's say I am a medium user, this green line here. So this is the embodied energy line, and my actual line, value must be this. Let's say this is x1, sorry, y1, I would say. This part is y1, sorry for my drawings. And then this value is kind of, let's say y2. This is the embodied energy part. And this y1 and y2 together will be the new point where it goes. So basically speaking, your real energy consumed line will keep traveling like that. So that is the total one. What we wanted to show is that the two components of the embodied energy part, which is a near horizontal line, but it will be having little steps. Say for an example, I have my house, I start painting it, so that embodied energy will go, okay, I have my house, then I decided to change my carpets or the tiles, floor tiles or anything like that, and it will increase. Let's say I have decided to put some new windows, then that will add on to it. So it is a maintenance kind of aspect that we're talking. So this particular graph is for Australia. I'm pretty sure different countries can have this situation. So these are the fundamentals and the basics of how we at the moment measure elements of the sustainability in real buildings. So what are the two most important things are embodied energy, energy-wise, embodied energy and operational energy. Over a full lifespan, that's the interesting part. The second interesting point is, if we do this as a the community of scientists and engineers, what we can do is we can identify these trouble areas which are not performing as good as it should, then we can improve that system. And then by doing that, we can minimize the embodied energy. So that's the whole idea. Still, the world is learning how to live how to minimize these carbon emissions. That's why we do all these type of things as scientists. So that's an important thing. Okay, now, so now I have given you the basics and the fundamental ideas inside what do you call actually in a building industry perspective? What do you call you're having a sustainable product, or you're very conscious about, very aware about the carbon footprint of everything nowadays. So then all this knowledge and research is built into tools. As you know, LEED is a green building tool, which is a USA product. I know Hong Kong has BEAM, BEAM. I didn't put it here. So energy rating tools this is a very widely accepted, almost a benchmark type tool. They are the leading at this point in time. They were the first to develop these things, so they are ahead of the game. But all the other softwares on measurement tools can follow or we benchmark against leads. BEAM is also Hong Kong is one of the countries which actually took sustainable construction very seriously from that continent. Europe also has a separate tool. We also have, for an example, this is the one which Australian made, which we are using, which is called First Rate 5. Actually, RMIT University with a small team of academics, including me in the research teams, have involved in a small contribution to this particular product in team environment. This is now, it was used to be very simple tool. Now it is very commercialized, full package. It's very, very powerful tool as well. So basically what I am trying to say is that, yes, if we recognize the basic principles, and then there will be tools to follow. So then you can use the tools. Majority of the people, there's a lot, very easy to use, and it's just a matter of selecting materials and types and positions, and it will calculate the overall energy consumption of that situation. So that's one of the things to recognize. So when we are talking about, and the other important thing countries are now doing is, like in Hong Kong, for an example, Hong Kong residential initiatives. I think Hong Kong as one of the countries having the tallest building stock, the biggest tall building stock of residential towers. The Hong Kong residential initiatives, you have residential authority, housing authority initiatives, very interesting findings, and a very active group of people when you look at the world. Their 2018-2019 report, environmental performance, is very good. Some it is in summary. They are very interested now in getting most of the residential building industry to modular construction, for an example. They are trying to, because normally residential towers are repetitive, like the units look exactly the same. Then that is ideal for modular construction. So they are pushing for modular construction for two reasons. It is very speedy construction. Economically is also not sound, and more importantly, because it is done in a controlled environment, which is in factories, you can actually control the embodied energy, and operational energy is particularly very well looked at. So one of the main contributions in Hong Kong at the moment is modular construction because of that. On top of that, there's another aspect in Hong Kong practice. to try and improve the, the situation is, of course, the speed of construction and any obstruction to the other road usage and things like that. Also, it is important that to maintain the air quality, environmental air quality within the city premises. When you must have experience every time if there's a construction going on, a lot of pollution in that town, any city that you go. So quite frankly, Hong Kong is kind of a leader in sustainable building industry. There is a lot of credit for them for that. Okay, so that is the basically the fundamental aspects what we have just discussed now. It is not directly important in your assignments or projects, but it is important for you to, in your assignment, if you say we will be asking for you to discuss a little bit about this, that is important to know. That's a basic fundamental aspect of it. We have not the water consumption, this is the energy consumption that we have done. The water consumption and water recycling part, we expect you to do a little bit of research from your side, and then discuss it in your project, how actually you can improve it. So it is that particular part we will leave for like your own research component. You can look at whether in Hong Kong practice or in any other a tall residential building, what are the good case studies you can find which does the water treatment within the same site, which means the wastewater recycling, rainwater harnessing and recycling, and minimizing the potable water usage. If you, there will be a couple of good examples worldwide that you can find. So we expect that. That's the other element. One is energy, one is water consumption. The other aspect, of course, is selecting the or greening the area, planting green facades, and there are lots of other initiatives are there in terms of making a building greener than it used to be. So next, what I will do is I will talk to you a little bit about the major assignment in this course, and then where to start and how we do it. So as I said, tomorrow workshops, design workshops, I should be able to probably help you guys, those who have not started yet, or those who are in the early stages. You can, we can discuss about how your sustainable home design, unit design, taken care of. I'm aware that this year, because of the situation of COVID-19 situation, that you had a face-to-face late start. So I'm hopefully you will have a better. I was told that I think from in Hong Kong you guys can go to the university face-to-face very soon, and because of that maybe you can do a little bit better when you have chance to discuss your projects with your supervisors and the teaching staff in Hong Kong. So let's look at, therefore, the next phase of my lecture is to just touch base with you. Infrastructure design, what is expected of you, what are the other elements we expect you to know through this particular subject, and also as I said at the beginning, we consider that you all have at least done reinforced concrete design uh, at least one part one, so you know how to use either your Hong Kong code, Australian code, or Eurocode, or whatever, doesn't matter. You can use any of those. Hong Kong code is perfectly all right if you want to use it as well. And Eurocode, I think, is popular in Hong Kong as well. So you can, there's no problem as long as you know it is compatible and it's correct what you're doing. So let's see what the project is. I see it in uh, kind of this is project-based learning. So overall learning can be put it into three bubbles, I think. One is I want you to have a as I said at the beginning, this project for the first time, probably try to see a little bit of creative ideas of yours, your design capability. Design per se, sometimes civil engineering, we think design is building, design and calculation. It is not. Design is also involved your understanding of typology, your understanding of how actually you can create nice spaces within a residential building, how you can organize your say for an example living areas and kitchen areas and things like that in a better way. So you can try that out. That's one of the parts of it. So interior layout design using topological and passive design principles. We like to see whether you can adopt your passive design principle. Make sure that you will not have on the west side a lot of windows, so it will be very hot on the west side of your building house, that you have large open windows. The sunlight will come streaming inside the house. It will be much warmer than you have the windows to your east side, which is at the morning light. And then particularly if you have your windows to about south side, it will be a little bit more cooler inside the building. So so the internal design, therefore interior design, takes a lot into consideration. How the movement of the sun, which side is hot, which side is cold. Even when you wanted to really buy an apartment or rent an apartment, you can really see which side is getting much warmer than the other. So what we are trying to do is a little bit of that in this project, to give a little bit of creative idea. And also this subject is also related to another subject which I offer in Hong Kong, which is the tall building, long span and high-rise structures. So there we will be actually designing 60-level building. So this design, we wanted to see that the students get in the third year a little bit of creative design side of things as well. Okay, that's the idea of this. So one bubble is that you want to look at your use passive design principle, get the interior layout as good, best as you can. I assume by now you have already selected your units. You know whether unit is type A or type B, type C or D. You know roughly whether it is facing north or south or east or west. That building has already decided where the balconies are. They already decided you can't do much about the changing the design, but you can reorganize the interior layout so that you can have your bedrooms on the cooler side, living areas to see the sceneries, and so forth. So hopefully you have already selected your things there. The second bubble was talking about the floor framing. What we like to see here is that I think starting from level 30 to about 40, we consider, okay, all of a sudden there's a very smart option was given where or if you wanted to develop building, the building plate, part of that building plate can be bought. So the house is not designed for you, but you can design the house inside that particular floor plate. So that's the idea. It is like in this country, we go and then we buy a plot of land and then we design the house inside that land. Very similarly in Hong Kong situation, what we are doing is we are giving you a floor plate. In that floor plate, there are 4 types of units in geometry. Only the external shape is given, but the interior is not designed. So interior uh, can be designed by you. That is the task that you have. So you have an interior layout plan. And also we like to, because it's a sustainability is one of the outcomes, we like to use what we call the interior walls, which are non-load bearing walls, because we are using all the load bearing parts as the shear walls. If you see in that plan, they are the vertical load carrying elements. So interior walls then become partition walls, just partition walls. Those are non-load bearing walls. So they don't have to be very thick or heavy, or you can actually use very smart material. So what we are trying to do here is, now one of the things in the sustainable field, or what we know is, we design for construction. Philosophically, over the years until now, what the humans did was, they designed for construction. We never designed for deconstruction. If our philosophy was to design something to deconstruct later, like the car manufacturers do, so certain parts can be reused. If you have a second-hand car, you can go to a place and then find parts for your car, and then you can replace it. But in the building industry, we never do that, because we design for permanently. Our design philosophy was designed for construction. Our main aim was construction, the economy of the construction. Our main aim was speed of construction. We never looked the design for deconstruction philosophy. It was not there. However, now this is now coming a little by little. If you look at modular construction is also a part of, you construct away from the site, brought it to site and assemble it there. It is a little bit like design for deconstruction. So we are not asking the entire building to be designed for deconstruction. It's too much for you guys. But what we are asking is now, internal walls, interior layout, internal walls, can you find a way of modularizing those panels, those wall panels, so that wall panels can be manufactured off-site and come and get connected on-site. So that's the idea, designed for deconstruction philosophy. So you have to illustrate the ceiling system. Services, of course, will be like that anyway. The ceiling and the interior walls, and also the walls, the interior part of these partitions to be identified as which can be deconstructed. Why do we say that? Let's say somebody want to buy your house a little bit later and then wanted to reconfigure inside the building, like redesign and reconstruct inside the building. So you can demolish, not waste them, but you can remove them carefully, and then you can redo it. You can change your interior by the second buyer, home buyer. So that sort of an ideas are coming through in the new industry. So it is very similar that you have a house on a plot of land, and then it gets very old, 50 years old, and then we do here, we demolish that house and then rebuild on it. But in major buildings, we hardly do that. But in this particular case, like a innovative idea, so we like you to try to think about it a little bit. So we are kind of pushing you outside the envelope now. We are not teaching you exactly how to follow the current practice that you can learn, you have learned in many other subjects. So in this design subject, we like it to be a little bit innovative and differently thinking pattern that we establish. And then, of course, green building fundamentals part. You can use the passive design aspects in your interior design. That is okay. But the other green building fundamentals like the water conservation, energy conservation type, you cannot illustrate very strongly in your design. So what we are suggesting is, can you do a operational and embodied energy conservation side? Can you discuss through your own small research component? We said in your, if you look at that in the course description, we said that there's a small self-research part come into play. So suggestion is that you look for Hong Kong tall building sector or worldwide residential towers, and then see there are, can be, we are asking you to study 2 case studies, real case studies, where the water consumption is, water recycling system is within that property. Of course, we always recycle water we collected during storms and then take into a reservoir and then clean it and then bring it. We take the wastewater to a central place and then clean it and bring it back to the site. This has been the practice. But now there are some buildings, what they like to do is to use this water consumption and water recycling within the site, particularly if we have, say, for an example, 1,000 houses residential tower, or say 500 houses residential tower, and then you can definitely on site do the water conservation side of things. So that is the part which requires you to do in your assignment. That is a separate element which I think we have given some mark allocation there. And then the third element is, of course, we like you to use your previous design analysis and design of your floors and beams. So after doing your initial interior layout, we would like to see you verify and confirm and design your flow slab. At the moment, we are giving you the flow geometry only, flow plate sizes are given, but we wanted to know what's the slab thickness, what's the beam size and depth, it is depending on. So you have to conduct a framing plan first, and then you have to do your normal code, use the code to verify deflections and how much of reinforcement you require and so forth. So that is the other element. So there are 3 elements. One thing is, of course, the interior layout planning, and also looking at that as the interior walls are non-load bearing partition walls, and then make sure that they are designed for deconstruction, which means panels can be brought. So it is not wet construction, it is dry construction. These are dry walls instead of wet walls. I'm pretty sure if you look at one of your old residential buildings, tall buildings in Hong Kong or anywhere, you will see that most of the partition walls are brick walls or block work, and it's very heavy concentrated loads. It is not very efficient, except the fact that, of course, your separation of units must be soundproof, acoustically sound, otherwise the noise from one house goes to the other. So but internal walls can be very lightweight drywall construction inside a building, provided sorry guys, this has gone, give me a second. Okay, I'm back again. Yeah, so what I was talking about, the drywall construction aspects in your design. So that goes with your interior layout. I have given few pointers here. Your design will be assessed on meeting the following key criteria and demonstrating capabilities and skill in design. So of course, say for an example, guys, in this one, what you can do is I can show you how rather than you are designing a beam and a slab separately, we can actually set up a space gas model where the entire plate, the plate under your house can be modeled as one floor plate. Here, floor plate is a combination of the slabs and the balconies and the beams. So if we can actually do a simple model, and then you can actually get the bending moment diagrams and shear force diagrams, and then you can find the reinforcements, how much of reinforcements required in that. If you know the N star and then V star values, deflection can be checked for serviceability limit state. That is what we would like you to do. So you can, I mean, if you want, you can, we have given you in the handbook, which we have given there, how you can do using the simplified methods given in Eurocode. I'm pretty sure Hong Kong should have the same thing, how to calculate indeterminate structure, how the bending moment of a continuous beam can be identified. Your slab is continuous anyway over the beams. So how can you do a 1 meter strip of the slab and then get the bending moment diagrams and then do the design? So, or alternatively, you can use either ETABS or you can use space gas, any structural design tool to do what you like to do here. And then that will be something exciting to do. So I, under number item 5, I have already mentioned the water conservation and other sustainable features can be only illustrated through some research. You can't do it from house to house. Of course, you can do it house to house by saying, oh, we're conserving water, we're very careful users of that, but entire building together would be much better. So these 7 points here will pretty much cover your what is expected of you. Go through them again. I'm pretty sure that you will have an opportunity to talk to your other academics, Hong Kong, our colleagues in your teachers in Hong Kong, so they will also guide you. Obviously, one of the things which you can think of is low embodied energy material, but in your case, it is very few choices there because the internal wall system will be dry wall system, and there's hardly any opportunity because the reinforced concrete is the main material used there. So there's a little bit of limited, but you can discuss about how low embodied energy material can be used. Say for an example, paintings and other finishes and things like that. If you can identify low embodied energy materials, and then you can definitely propose that's the case. Even in the internal drywall construction and finishes of the wall, you may suggest some low carbon footprint materials. So these are the 7 points which you can think about. There is another thing that we, this particular slide explain. I think this will be managed by your teachers there. How you work with you're having a professional conduct, you are training for a professional job in future. So there are certain requirements of the engineers, Hong Kong Institution of Engineers require you to demonstrate. So this can be included in the list as well. So the first 7 which I have shown are definite design aspects. These are your capabilities, your character, and how you conduct yourself. You do an honest job. You refer properly, and all that. So this will be also taken into consideration in the way that you design, the way that you communicate with your supervisors. So it is important that that part is covered. So these are the mark distribution. You should know at this point in time. This is the final report mark allocation. You will be having a progress review kind of work at the mid stage that is being identified. Please go to Canvas, go to assignments, and then read through the assignment criteria, and then you will be able to get that there will be mid-semester mark, and then the final one is the and then you will be having a poster, and then you will be having a poster presentation. You don't have examination in this one. So it is a presentation side that you will be using. Okay. Now we are kind of halfway through the 3-hour session. If you want, you can have about 5 to 10 minutes. What I will do is I will start the second half of the lecture, hopefully 5:40. I'll take a 5 to 10 minutes break, and then I will start that. Or if you wanted to really ask a question now, please raise your hand and switch on your thing. I'm happy to answer that question. Or during tomorrow's workshop, we can ask specific questions, because it is going to be discussed your type of the unit. So I will be, as I said, I will be meeting A and B groups in the morning and C and D groups in the afternoon. So we have time to go through your design. You can upload your design and share with us if you have already done. One slide would be sufficient so that I can give you some feedback quickly. So we have plenty of time tomorrow to do that. So I'll take about 10 minutes, unless that you have questions. Please raise your hand and ask. Otherwise, I will see you guys. I'll come back and join you 5:40. Okay? Everybody happy? Okay, guys. Take a quick short rest, and we will take it from there. Hello, everyone. Okay, we'll now start the next phase. Okay, so we will discuss the passive design aspect a little bit, and especially how you can use it in your plans and your uh, units as we go through that. And that's the idea of this session. And then we will have a little bit of discussion how to utilize space effectively using what we call the typology kind of concepts. Okay, guys, as I said, passive design principles simply means that how you can actually harness and then make use of the path of the sun, depending on whether your east side or south sides and north and west sides of any particular building or a unit in this particular case, part of your boundary is inside the building, so that side will not affect much. So in your case, all 4 units, if you look at the outer periphery, that is what is being affected by the sun's movement and sun rays coming in or keeping out. So the passive design principle is a form of set of principles by which that the residential building can be improved for its thermal conductivity, thermal comfort, and then as a result, you will be saving a lot of energy, mechanical energy, which means the fans or the air conditioners, heaters, and so forth. So that is the idea, because the solar energy, sun's energy, sun rays is does not have a cost at the moment. There will be a time and there's a discussion going on whether we will be having in future to pay for our oxygen, for an example. Um, Sun, I don't know whether the sun rays are going to be natural sun rays are going to cost one day for us. But at the moment, it's no cost to us. So and also not only the thermal comfort. Say for an example, you can design a house, right? Even the limited out outside out periphery in apartment like situation, where you can actually invite the view, outside view. Um, um, uh, well, yes, Fat, how can I help? Hello, hello. Pink, and do you want? Yeah, is there a question? Okay, okay. Um, so, uh, so therefore, you can actually create a very pleasant indoor environment with improved thermal comfort and low energy bills. Passive design principle also enables conservation of energy, maintain thermal comfort. I think this is a little bit repetitive. Um, it involves orientation. Fat, is there any question that you want to ask? Maybe your speak is mute. Hello? Hi. Okay. All right. Okay, I have to lower your hand because. Okay. So let's see how we can actually really see how this works. Now, what you see is, of course, the world map. Now, I'm showing here, I'm in Melbourne, which is on the lower side a little bit here, but um, this area is kind of Brisbane and Sydney area. Um, Brisbane and Sydney area. I'll be somewhere here, by the way. We are a little bit in a cooler climate. And then Hong Kong is slightly somewhere here. Now, the Sydney, Brisbane, and Hong Kong, we categorize as warm, humid kind of temperature setting. So from the equator, so if you look at where around 33 degrees sort of altitude, you will be finding both countries are very similar. However, what is the sunspot effect on Australia? If you mirror image, you will find it in Hong Kong. It is not exact, it is the mirror image of that. So say for an example, if you are in Australia, if you wanted to design a building here, what we try to do is we have to put the longer dimension of the building with all the windows and things like that to the north side of the plot. So if I'm going to buy a apartment, say for an example here, I would look for an apartment which is having the northern side windows. That will give me a very, very good, much better, relatively much better one than, say, for an example, west. If you have a west facing entire large windows sort of surface, then your home will be very, very warm. North is pretty pleasant here. But in your case, actually, the south side will be very, very pleasant. Not the north side, because it is the mirror image, because we are below the equator, you are above the equator. So latitudes and longitudes make that variability. So idea here is that that position of you in the planet will determine a set of principles which you can use for your home design very well. So that's the idea here. And the similarity. Now, in Australia, for design purposes and all the other purposes, we divide into 8 zones of weather, weather conditions. So kind of Hong Kong situation is very similar to the zone 5 category, say Brisbane and Sydney somewhere up here. As I said, we Melburnians are around here, so our temperature is between, say, zone 8 and zone 7 and 8 kind of area, cool temperate, I would say. But Hong Kong, which is very similar to ours, is up there. So whatever the principles that we are using here will be useful to you guys there. Similarly, if I'm designing a house here in Melbourne, which I did my own house here anyway, I'll be using the north-facing principle as I explained to you. So the simple point that I want you to realize is, when you are designing or you're buying a house or an apartment or whatever it is, you'll be surprised that if this knowledge is with you, if you ever have the choice, and then you can use it. That's a little bit of the knowledge help. I have given here, guys, I'm not going to read every one of these lines. I have given here this one and the next slide, for an example, 12 pointers, 12 points, which directly relevant to Hong Kong condition. So you have here passive design principle for warm, humid environments, something like Hong Kong. This very clear set of guideline that you can read and understand. It is not very, very hard to understand. of course, the point one is obvious. I have already said. Now I just introduced you to the Hong Kong is in the category of warm, humid climate. Therefore, you can understand its strength and weaknesses, and then you can use it to your advantage in your unit design, if I may say. Uh, there's a term called diurnal variation, which means the temperature variation between daytime and the nighttime. It is very less, 2 to 5 degrees. Say for an example, in Melbourne, it can be 25 during the day. On the same evening, it will be 7 degrees. But in your case, in Hong Kong, the temperature variance is not that high. So that's called the diurnal variation. It's very low, between night and day. So how you have to design for that is slightly different. Humidity is high. The other difference in Hong Kong and to that of Melbourne, of course, the same difference is therefore between Melbourne and Sydney and Brisbane as well. The relative humidity is very, very high in your region. Therefore, AI has a lot of saturated uh, for the same amount, say 80 to 90% humidity means the air is 90% saturated with vapor, which resulting in sweating, and also during nighttime, if 3 or 4 people live in a smaller space, even our body temperature variation can be felt by the combined together can add very inconvenient and uncomfortable environment. So in this situation, evaporative cooling evaporative cooling, which is effective in arid climates, which is like the one which we are talking about, are not effective or suitable in your situation. So the cooling type, and I know majority of the cooling systems there in Hong Kong are air conditioning. Here we call, in Melbourne, we are using what we call evaporative cooling system. That is slightly different and less costly, but in Hong Kong, that will not work. That is because of the moisture content in the air, which the relative humidity is very high. But what you can do in that region is creating natural cross-flow ventilation cycles. If we are smart enough, you can have chimney effect, what we call the hot air rises up. Therefore, the cold air is trying to get into that vacuum. And then if we can use that and generate design outlets and louvers and openable windows as such, so you can create a cross flow inside your own house. It is a little bit relatively harder to do between units, but you can actually really smart enough to try and visualize how you can do that. It is a little bit difficult in the when it comes to a small units, but in a larger unit, you have a choice to do that. So you will be able to choose this type of facilities. All what you're looking for is where is hot, and then that particular air will start to rise up because its density reduces. And then the lower levels, if you put the louvers at the lower level, and then it will suck external temperatures, provided the at night time where the external temperature is cooler than inside your house. That inside your house is, as I said, um, uh, the inside the house, because of the body temperature and everything, you can have a situation where the temperature is rising, whereas the outer temperature is not that high. Alternatively, you can have a situation where outer temperature during daytime is greater than that of the inside of the house. So you can design what we call the cross-flow effect. You must have heard about this in your normal terminology quite effectively in the climatic condition, like here in Australia, Sydney and Brisbane situation, there in Hong Kong, which is The other issue that you guys have is the large amount of moisture anyway, because Hong Kong is very close to the sea. So sea breeze is fully saturated in that situation. It's not going to help. It is the other way around. So sweating and other thing. So strategic positioning of thermal masses inside in combination with reflective surfaces and so forth, you can have these cross flow ventilation patterns established. It's a little bit of a specialized area. Um, you require data inside and outside and things like that to properly design it. But you can also conceptually design it, knowing that, okay, this is my west side, I have a window, that the air in that room will be very, very hot during some periods. Is there a way that I can get that air out so that it creates a draft where the cooler air can be drawn in inside the house? So sometimes, say for an example, you're inside of the building is air is maybe much cooler, so you may be able to get that air in and around the, say, lift area and the foyer area before you come into your home. That air can be sucked inside your house, and then cross flow can be established if you carefully design your openings and louvers and things like that. That's the idea. It's a highly specialized design, actually speaking. Um, but it is important that you know that is possible. Nowadays, there are a couple of buildings, I mean, entire tall building, they purposefully have a second skin, and then they make sure that the top air is hot, and then it will draw cooler air inside the building, traveling vertically upside, cooling the facade. So you're kind of having two facades. One is external, one is internal. So there's a draft of cool air from the bottom is drawn towards over the height of the building. And then you can model these things very accurately now using ANSYS type software. And then you can, this is called the chimney effect. You must have heard about the chimney effect. So why there's a chimney above a fireplace is because the fire area is hot, so the air is trying to climb up. So if you provide a chimney, that it will climb up the chimney and exhaust will be at the top, and then by doing that, fresh air will be sucked into the um, uh, heated area. So you can do the same thing to an entire building, or you can do it to a house by house. But if you have a two-story building, it is much more effective. Two-story apartment, much more effective than you have a single level. Single level, it is very hard to get that draft going, but you can still do to some extent. The other things is also given here, lightweight interior walls can speed up cooling at night. So that is why I said dry wall construction may be much better than you are having like thermal masses inside, because during daytime it absorbs heat, and then at night it release that heat. And then when that happens, if you have about 3 or 4 people there, that will be very uncomfortable at that time. Of course, then you have to have fans or air conditions to cool yourself. East-west walls should have little or no, you can see this statement 9 statement is very important. For Hong Kong condition, east and west walls should have little or no windows in order to exclude the low angle east and west sun getting into the building. So you can see the hot surfaces will be your east and west sides. So try to private areas, west and east is okay. Resting spaces such as the bedrooms are like. During daytime, it will be slightly different. North and south walls should be open as possible, as best as possible, to allow for cross ventilation considering wind directions. This requires that the plan arrangement should avoid double blanked rooms. one of the reasons you will see that I have the units which we have chosen is fairly relatively larger compared to the normal standard Hong Kong interior houses. I'm aware of it. One of the reasons we have given it that way is so that you can visualize and try out these little things. You can exercise it in this assignment a little bit as much as you can. Mind you, guys, nobody, even a very experienced designer and a specialist in the cross ventilation design or the softwares available, you will not be able to satisfy every and all conditions at all. All what you can do is you can reduce or minimize and then get some minor benefit. Mind you, even inside a house, is 2 degree difference is a big difference. 2 to 3 degree difference is a big difference. So you do everything you possibly can to try and make that it that way. Now, point 11. You can see that you can use windshields, reflectors, smart blinds, tinted glass. There are lots of products now coming to take into consideration these things. But in a general house, it may not be, but in a hotel-like environment, people can afford it, and then those type of things, but not necessarily in everybody's house. But it is important to understand this. There are techniques available, methods available, improved products available for you to suggest and utilize. I know in Hong Kong, you guys are using in your tall buildings what you call the projecting wing walls. This wing walls does two things for the thing, very similar to that chimney effect that we have just mentioned in a tall building, where you can actually have a cooler air drawn from ground level, and it can made it travel up the surface and then exit from the top. And then by doing that, having a two skin facade, the inner facade size, inner skin will be much cooler situation than the outside. So you can actually generate depending on the orientation and proper fluid dynamic kind of modeling and analysis, you can actually really analyze that chimney effect quite effectively. There are a lot of papers which published on these things anyway. The other one is as I said, there are two reasons for that. You can actually form, these wing walls can form a shadow so that you can protect direct sunlight from that wing wall, very similar to in a harbor that you will be having a water breaker, for an example, little wall which is going there so that breaking the current. Very similarly you can do it. And also Hong Kong uses this one for noise, traffic noise and noise management as well. Many countries do that in buildings. So you can actually create shadows like a sunshade. You remember there's a long time ago, the window can be provided with a sunshade. You may have seen many old residential buildings in Hong Kong has these tiny little wings like flat edges coming out that is to cover or to provide a shadow, cast a shadow to your window so that the window is not getting hot, straight sun rays hitting on, but rather the wall get that. So you can also effectively position these walls in such a way that the cross ventilation and also the vertical chimney effect can be maximized. It's a very highly scientific area of modeling, which is pretty, there are other guys who are doing where to start and things like that. The first and foremost is the selection of your units. I presume that majority of the class have already allocated a unit. If you are not, if you, allocated as yet, please contact your staff member in Hong Kong, and then he should be able to, your teacher and the course manager there, and then they should be able to arrange it for you. As you can see, that it is very important for you to realize in which direction that your unit is oriented. So I have given the north to the left-hand side of the slide. There's seascape to the east, which is to the top. Of course, if the north is to my left, east towards my right-hand side, and then the west is to my left-hand side, and then the south is, of course, the opposite on the right-hand side. So you can, this orientation is a very important in your interior design. And then the next phase you have to look for is, okay, where are my openings and things like that? Are they oriented in proper way, or is this facing west and south, or north and east, and or north only or east only? So you have to be aware of that. So it is very important you identify that. Of course, the levels, I think you're given 32 to, I think 31 or 32 to whatever that is. I don't think that is a major issue at all, because the flow plate height is not making a huge difference. It is the plan, and the north, south, east to west identification is very important. Yeah, level 30 to 38 is being the typical flows. The idea is this, guys. There was a major developer who has actually have lots of smaller houses, but he has decided to sell the flow plate area apart from the load bearing walls, shear walls, which you can see, large shear walls, the core, and also all the thick, all these dark black color walls are proper load bearing walls. So you can support your slabs through that. And then, of course, from the lift, you will know which is the opening. Unfortunately, unit C is not well illustrated here. If you go to the next slide, you will find unit C clearly. It is important to know, okay, I'll get down from this lift, I come through that, that is my main door, kind of a thing. So you can see in some units, you have two possible openings, entry points. In some, you have only one possible entry point. So you can utilize these spaces. These are very large spaces, guys. So the idea is like, okay, if you are rich enough, or if you can afford, you will be purchasing this part of the floor slab, and then you will be doing all your interior design as you wish. It is your dream home, the way that you want it, not the way that someone else has designed for you, the way that you wanted to design it for you. That's the idea. That's the simple setup of this project, so that you can use your intuition, you can use your creativity, you can use your skill of identifying the spaces, orienting it properly, and then identifying what needs to be included in your house. Do you need, I mean, do you have the size of the house? How many bedrooms you can could get there? Whether you will utilize this particular floor area very effectively, or whether in your design you have put few walls and rooms, and then you had not actually thought about what we call the typological interior planning aspect of it, the house, which means a relative positioning of spaces, which gives you the best outcome for your interior design. So you have to, our intention is that you as a third year engineering student is getting excited about it, and then trying to do as best as you can in this type of projects. So it's very exciting when if you start enjoying the project, it will be very, you may not like it if you're not enjoying the project. But if you enjoy the project, students take a lot out of these type of projects. I can assure you that. Okay, so this is the floor plate. We all know these are very large areas you can actually really design well. These sometimes these small units also can be very effectively used. One of the things that you have to be a little bit careful of, it is not absolutely a big difficulty, but say if I am having toilets and things like that, sewer system, of course it is not the wastewater from your sink or kitchen, it is the sewer pipes. If you have the toilet, your cistern and the water closet, and then you have about 4 inch, at least a 4 inch diameter pipe. Because it's sludge, it is semi-solid, you have to have a particular slope. So you are trying to, it cannot be done always, but you try to see whether you can have your bath toilet setting, not the bathroom. Showers, no problem. Water can, it is run in a 2 inch at most, 2 inch pipes, and then it is not a problem. But it is the toilets flushing which requires. So these are the service ducts. These are the ducts through which electricity, water supply, gas, all services, plumbing, and all inputs as well as all outputs. So electricity, water, air conditioning, ventilation, everything climbs in the building through these ducts. So service ducts. So sometimes you have to be smart enough to use these ducts, that area, the voids, I would say, to get your services going through. As I said, water supply not a problem because it's a pressure thing. No problems. It can go around. Wastewater, it has a little bit, but it doesn't need the same slope as the sewer. Just type and say sewer line slopes, Google what sort of, so if it is PVC, what will be the slope? It is, you will be using PVC most of the time here. You will be having your slopes, and then you can find if it is to travel 10 meters at that slope. Okay, if it is 1.5 meters at the outlet point, which means that the pipe has come out of your ceiling, and then you cannot put it inside. So that's the simple calculation you had to do. Every meter, it has to drop, let's say 1%, which means that every 10 meters, it has to drop 1 meter, right? So, so you have to visualize that particular sloping pattern, and then it is just a drawing, a little drawing. Okay, if I have 0.5%, so you have to check what the slope, recommended slope for PVC sewer pipe, sewer outlet. So that is something that you have to be a little bit aware of. Worst case scenario, what will happen is you have to have you lower the ceiling at that point locally, so that your pipe has enough space to run underneath the slab. So those are the little things that constraints, but otherwise these particular cantilevers, cantilevering slabs indicates to us that they are probably can be used as balconies, and then you have to be a little bit smart enough to design this. You can think of in smart way. We will discuss this in our design classes today, tomorrow workshops. With the how can you actually really frame it in such a way this doesn't work as a cantilever. Okay, you can design the slab as cantilever, or can you have a little beam, H beams here, and then make this particular slab spanning horizontally. So those are the little key things that you can think. Say, for example, can I make my slab sloping that way by a trick, rather than it is working as a cantilever? So you can visualize both sides that we will play with tomorrow. So guys, you know your unit, you know your position. You should be able to now. One of the things that my experience with the previous classes, so they don't really visualize, my entire space here is having large glass windows of facade. Um, and as a consequence, I'll be having a lot of sunlight here. Sometimes it can be good, sometimes it's not that good. But we know generally in your part of the world, sun is rising from east, it is setting on the west. So the sun's path is from the climbing that side and coming out that way. So north is not that hot, but in some during the summer, I think north uh, may have a slightly little different um, angle compared to the west. So you have to think about those. But in the smaller units, you have not much choice because you have only one little section as a windows. You have to utilize it best. Of course, when you're coming inside the house, you like to see your living areas and things nice. And then you have very nice scenery. Say, for an example, in one side doesn't look good because that's a bad dumping yard, and then the other side is the east side. I think it is a nice area, so you have to visualize those things as well. So it is an interesting exercise, and then it involves a little bit of thinking and a bit of challenging as well. So that's what we are going to discuss tomorrow. So I assume you have your tick here, wherever the one that it belongs to you, and then you will be working with some other colleagues, so you can discuss with each other, come up with good solutions. Now, it is most of the time I found that our students don't get this one right. So that is why I think you have to go there and then you visualize, yeah, my north is here. So if I have to put this one in a horizontal direction, this unit A, say for an example, I have to turn it anti-clockwise, and therefore the north side turns should go with that angle. So obviously, to help that position, I have just given few hints. Okay, for this building, your north is here. So your if you look that side, and then your east is here. You don't have, because the building is there. Therefore, this east is covered. Um, but you will be having your west side is here. But luckily that you will be having smaller windows there. So that is the west side. And also when it is west, um, uh, if you look at the time, this may be putting a shadow on this side of the house. Therefore, it may not be as bad as you think. So those are the little things that you have to think about carefully, and then enjoy your design. Yes, as I said, every design, you cannot design for everything. You can design for certain things and get the best outcome. There's no exactly correct answer. It is a better design or a poor design. It is not a perfect design. Nobody can get a perfect design under the constraints that you are facing. Of course, if you have the free, I have given you a blank paper, and then you could have done it. But in this case, you can't do that because orientation is fixed. That is the challenge that you're facing as a third year designer. Okay, unit B, again, I'm indicating where the north is for a type, because sometimes I find the students haven't struggled identifying it. So in this case, north has a blind wall. This is probably I can't remember which side is the interior. There will be an interior side. This looks like the balconies, which means this is the outer side. And if this is the outside, it is southeast corner of that house, this particular house. So you have to try and visualize how this can be done. Now, this type of situation can be little bit, this area can be little bit tricky when you start spanning beams and slabs, because there's hardly anything to support there. So you must be a little bit strategic about it. This one seems fairly large. The CAD drawings were given as well. I think for A, B, C, D, you can get the exact dimension. This looks like a little bit bigger cantilever compared to this one here, for an example. So it is an interesting exercise when you want to uh, do it that way. Uh, so this is the part which we will discuss tomorrow. And especially if you have a interior layout or an idea of an interior layout, it will make it very interesting, because you can probably show and then get a quick feedback, so the others who are listening also can get an understanding. So idea is this: creating a pleasant home, interior layout, design consideration. What should we look at? Optimize spatial requirements, sizes of living. You don't know. One of the things that most of our students are struggling in Hong Kong, because most of the houses that you are living in very, very tight in spaces. So please forget that. You just imagine that you are designing this structure, this building, for as a high-end uh, uh, space requirement market kind of situation, or don't worry about the cost of it, and then just say, okay, this is a very large penthouse kind of a setting here. But or alternatively, you can think, okay, no, I am designing this one. This is a project which came your way, and then there are a lot of Hong Kong contractors designing houses and residential towers in Australia and other places in the world. So this is equivalent to a real situation in Australian context. This type of area is really large. If I tighten it, I think you will be more stressed to get the best result for that. So don't worry about the sizes. It will not be the sizes that you are used to. For that reason, I'll just jump into the next one for a minute and then show you. I have given here roughly what I call the approximate room sizes used in contemporary Australian home designs. So, say for example, formal lodge and dining, 3.5 by 5 meters. Some students told me, Sama, now our full house is, the house that we are living in is kind of 2 times that or something like that. So I do understand that. But what we are after is that you should be able to design not only for Hong Kong conditions, for other parts of the world one day. So you need to know that there are certain different sizes and things like that available worldwide. It is changing from place to place. Different countries have different requirements. So there, I have given a rough idea of what the bedrooms and living rooms and lounges and also you can see bathroom, toilets, lounge and storage, kitchen, corridors. Of course, you will be having, you may like to have gymnasiums or gym, small gym. You can have study rooms, you can have bedrooms, you can have walk-in rooms and suites attached to master bedrooms, and then so forth. So it is your dream home. So you design as you wish, but the learning will exactly the same. Either way. So please remember that there's a little table given. Don't go arbitrary and then worry about the space. Corridors normally, guys, I would put 1.2 meter width. It is mainly because of this type of house for furniture, getting the furniture in. 1.1 will be very tight, quite frankly. Long corridor. So you normally have 1.2 is reasonable size. So that's the dimensions given there, rough idea of spacing. And then in your report, you can put a nice pie chart and then say, okay, my bedroom, this is the total area. My living and dining, this is the percentage of area I have used. Kitchens and bathrooms, I have used this. Corridors and other undefined areas. So you can have a distribution of your area known very reasonably, and then you have a safe family of 3 or 4 or 5, then you can justify, okay, this is what we have designed for. Sometimes because you are young, you think you are going to be young forever, and then you think, oh, someone I'm designing only for myself. uh, so um, that is if you're going to stay there forever. But what if you wanted to sell that apartment to somebody else? So you can think. I think, averagely about at least designed for 4 people. There's enough space there to do that, at least for the second-hand value. Scenic aesthetic requirements, I'm pretty sure you're pretty good with that. You will definitely try and see what you do, and you can explain that in your design reports and things like that. Passive design consideration, this is a very important aspect to discuss, therefore please give a little bit of a thought in that. Privacy and restricting entertainment consideration. Say for an example, guys, if I am designing a home here in Australia, I design my own home here. I have many people doing that too. As I said, the northern side is the most efficient side in terms of passive design principle for Melbourne condition. That may not be exactly the same, which is the opposite of it in Hong Kong. Um, one of the most important thing you have to think about is if you can get the scenic angles in two points of a house. I always say, in this setup, one of the simple principles I did was, okay, no, in any major space like living area or family area, things like that, I said I need to have 2 line of sights towards my garden. That's one of the principal decisions I made. So which means 2 angles towards garden, which means I'm inviting the garden inside my house. For whoever sit in there can see 2 ends of the garden. I'm living here in a 2-story building, but every room has at least 1 direct angle to the garden. This is a separate plot, separate room, but those type of broad design themes can make you a good designer. You first decide that and then see how you can accommodate it. Don't go overboard, but say, very simple principle. Say, no, one of the things which I want you to do is when I say in every part of my house, I need to see my garden at least in 1 angle, preferably in 2. That means you open up that area straight away, but that is for single plot, single setting, but your one is a little bit complicated, but you can't, what basically the point which I'm raising here, simple rules, simple value propositions, a statement can make you start thinking completely differently. So that is something that you can practice in this type of work. Personal taste and needs of the occupier, of course, is your dream home. You know what you need and what the space is for. And then you can, if you're an artist, you will be different to that of your reader. I will put a library opposed to I'll be putting a painting room kind of thing. So it's totally different. Door sizes and things like that, guys. I know that you guys are not very familiar with this. It is important to write also to Google searches and things like that. See, okay, so if you go to our typical standard door sizes, boom, there will be plenty of suppliers who will be providing you door width, door height, window width, and things like that. So you know in your plan what's the width is. Of course, you don't know what the height is. The height is important. That will determine what the beam can be supporting the slab. What is the ceiling height? Of course, the floor depth plus the services allow about 250 to 300 millimeters for the services, and then that will determine the ceiling height. So if you over design your beams, you will be having a shorter or a the floor to ceiling height will be less. Normally in a tall building like this, just imagine if you have a 100-story building, if you can say 50 millimeters floor to floor height, floor structural depth, that 50 millimeters time 100 means that it will be 5 meters, which means you can squeeze another entire floor. So in tall building design, a design of this type kind of stuff, very important thing is the slab, not the slab depth, overall floor plate depth, which is the structural depth of your floor plate. In this type of design, you're not thinking about a beam in isolation or a slab in isolation. You think as the floor depth, entire floor depth, which is from the top of the floor finish to the bottom of the bottom soffit of the beam. Let's say you ended up being a 600 millimeter deep beam, and then if this is about 3 meters or 3.5 meters, then you have to add another 200 millimeters or so for the services, 250 minimum and 300 preferable. You remember I was talking about the sewer pipes going through. So if you're upstairs, dweller is requires 3% or 2%, the toilet aspect has to be, therefore the sewer line has to be kept length is as short as possible to minimize the overall jumping out of the ceiling. So the ceiling height, what I'm trying to say is ceiling height is a floor to ceiling height is a very good measure to see, to tell us you have done a very good job or you have not thought about your design. So it's important, therefore, to have, so now, say for an example, how we find whether your design is efficient in this type of stuff is by saying, okay, someone, I managed to get my flow depth to be this much. So that tells us that you have actually really got a good solution for your flow framing anyway, in order to do that. And then you say, you wanted to shallow beams so that you have put so many cross beams, and then you have so many lengths of beams as well. So you have to try and visualize and then simplify your thing. My suggestion is that think about not a two-way spanning slab. Try and visualize whether you can do it one-way spanning slab. I think in the brief I have said it somewhere. So I think that is not a bad idea to do. To start with. I hope that you got taken down a few notes as I go. So personal taste, selecting color schemes and things, I don't think this comes strongly to you, but if you wish, this is another way. The design is one thing, then architraves, curtains, cornices. Cornices is the connection between the wall and the ceiling. Architraves are the ones which are around your windows and things like that. The skirtings, of course, you know, the floor. Most of you guys, I think, last few years I have been doing this subject with you guys since 2004, sorry. A lot of students, Hong Kong students are working students, sometimes from industry, sometimes they pretty well know what I'm talking about, hopefully. So window furniture means here, window furniture really means curtains and other things. These are the things that designers think, but I don't expect that you to do it. I have listed it there just for the completeness of the discussion. Okay. I have another nearly 15 minutes. I can either go through this or this is, if you read it, all what I am showing here is nothing but how an architect, you are not an architect, you are an engineer, but I'm just explaining to you how actually a flow building design come to play. Is it start with that you are doing calculation on a beam, or is it completely different? So when you were learning steel design or concrete design, or what you have done probably would be selected a beam, check it against your um, against of course the capacity of the beam and the loads applied onto it. That I consider your designing element by element. And this project is not that. That comes last. That comes as the last one. In real life, that comes as the last one. First, you have to have a plan, layout, framing. You don't know what's the size of the beam, but you need to beam there. And then only you go to the design code and then identify the beam, calculate it, and then size it up, and then find how much of reinforcement. But in all design subjects, so far, probably what you have done was the other way around. You were given a beam span, and then you know the loads, and then you apply dead loads and live loads, multiply by 1.2 and 1.5 or whatever. I know that your dead loads are a little bit higher. It is 1.3 or something in Hong Kong. I can't remember, but live loads in 1.5 and so forth. So now, for the first time, you're looking at a starting from scratch, like conceptual stage of design, and then you have to interior layout and all that. So in order to do that, I have given you a couple of slides how actually if a client has a building design in their head, they wanted to hire somebody to do it because they're not specialized in doing that, and then that would be the architect, and the architect selects the structural engineer to work with them together, and the mechanical engineers and service guys, services together as a team, and then try and work through the process. So that is how a normal building come to life. So I have given here a couple of steps uh, explaining that. A particular interest is that it is very interesting to know, for those who have not work experiences in work practice, if an architect, their actually original thinking and planning is called drawn not in straight line, but like a bubble diagram. These are called bubble diagrams. So the bubble diagram here really means is that they're free in mind to do what they like to do rather than worrying about a grid or a dimension. Once that bubble diagram conceptually identify how the spaces are relatively positioned, located, this is what you call the typology of the design. Where are the spaces? How do they relate to each other? Should we have the kitchen right next to your master bedroom? Or should you have a toilet right in the middle of the kitchen? Things like that. So this is the typological consideration in a designer's mind. So I have given these few slides for you guys to visualize this one and then see how you can do the same thing. It is a little bit restrictive in your case because your load-bearing shear walls are already there. Inside that shape, it is not a nice rectangle or anything like that, but inside that you should be able to find the space. So no dimensions. And then what they do is then identify a connectivity, which is the corridor, or what they specifically call the circulation. See this particular terminology here, circulation. What is that circulation mean? It is not the air circulation. It is the people circulation. People movement from one place to another. That is what it really means. So I have given this one for you to learn from it and then visualize. Then only little by little he started to find the grids and sizes and things like that. So the first thing an interior designer would do is a bubble diagram. For an example, if I'm doing a design, I'll be first thing is where is my driveway? In this country, you have a driveway and you have a car garage. Everybody has that. So I was to drive. Okay, that's my vehicle. That's where I come. Okay, the next one I find is okay. from there, can I enter my house without going out the garage again and coming? And then the next one, I think, oh, how close that to the kitchen, so that if I go shopping, and then I don't have to walk through when the visitors are there, all the shopping stuff. I can actually have a direct or close connectivity to the kitchen space. Um, so that is how it started to happen. That's what you call the topological aspect of this, the spaces. And also, say for an example, if you are designing a separate house, I'm thinking about, okay, I have 4 areas: resting places, utilities, utilities areas, resting areas, common areas. That is my starting point. What is the common area? Common area, everybody can come together, like the living room or the dining room, this common area. What is the utilities? Utilities are the kitchen area, laundry, those type of areas. Resting areas. What's the resting areas? Resting areas, bedrooms, and then the children areas. In this type of countries that we have children retreats and all that. Don't worry about it. But say when you design something, that's the ideas that you have to have, and then by doing that, you become a better thinker, better engineer, better, better, better. You will start visualizing things. So that the relationship between within house, say for an example, if resting area or can be coupled to reading area. Reading area can be an office area, but the bedroom areas and the family areas and where the TVs and things like that can be a little bit separated, because that noise will be always there. Therefore, the other persons will not get disturbed. I know in your age, in your as a student, you don't see it that way. But the purpose of this whole subject is you to think like that a little bit. So get this project task a little bit seriously, and then I'm pretty sure that you'll learn a hell of a lot to that. Now, what is this architect does that? Okay, he has decided, okay, this is or not, this is a plan. Originally, he understands the plan. What he does is, he now on that, he trace with a butter paper what the elevation look like. You can see that there's a person standing here. So you can see this is the elevation, but these dimensions are exactly matching, right? So that's how the cross sections are being developed. So, and then further detail comes into play. So they are coming a little bit further, more details, a little walls appearing, openings appearing, doors appearing. If you have two face-to-face bedrooms, say for an example, I would not put the door right next to each other. So there's privacy, there's no privacy. I would have staggered in a corridor. If I have two bedrooms face-to-face, I would put one on the left-hand side, one opening on the left-hand side end of one room, and the other one is on the right-hand side of the other room, so that you have privacy. So the simple things, but makes a lot of sense. And also, it will improve the acoustic quality inside the house. What is acoustic quality inside the house? Which is the noise level. When you want it to have rest, you don't want it to be disturbed. So you can actually design spaces with such a level of insight as a good designer. Of course, you guys are doing this for the first time. What is important is for you guys to really enjoy it and then get these ideas as much as possible. So you can see now it is emerging well. And when this is done only, guys, that our framing plans come into play. So 8 by 22, this must be in inches, of course. So 22 millimeters, 22 inches deep, which is about 400 I think, and the 8 inches wide, which is about 250 beams or something. This must be steel beams. We do not, it is not necessary. Then you come up with a framing plan. That is what we are going to do tomorrow workshops, framing plan. First, you don't know what the size is. What you're doing is identifying where the support points, see entire thing as a plate, which comprises of concrete beams supported by the shear walls and then on top of that there's a slab. And then you will start calculating your beam for deflection and ultimate limit state stresses and things like that. That is exactly what we like to do in this subject, that process, rather than I give you size of the beam and then say it's continuous, otherwise you do the calculations and then say it is okay or not. So this is slightly different in that sense. See this person, how he drawn his truss on that particular large uh, uh, space, probably a good sanctuary area or a meeting area or whatever. So the truss is already drawn. Um, ideas starting to come so that the visualization of elevation and the plan is overlaid on each other using butter paper and then sketching freehand. That's what the architects do best, because they don't want to log themselves in. Um, Otherwise, the innovative thinking drops because they're fear of whether you can get the beam working or not. So anyway, so the key, so then you will see that how this evolvement of this uh, drawing started from here and then moved towards the final one. What so far in design subjects, guys, you have done was, we have given this geometry, you have gone sideways and then look at the beam sizes and reinforcements, or you say I-sections or whatever that may be. But that's not what we are doing in the subject. We are doing in the subject this process here. That will give you a feel of what is happening. I think time-wise, we are almost there, guys. I almost spoken about 3 hours continuously. I wouldn't mind taking questions from you the next 10 minutes. These things are, of course, you can go through these slides and read. These are simple stuff which you can understand. I don't think there's any. This is one of the major developments which has used the construction for design for deconstruction. This should have been DFD, sorry. Design for deconstruction. This is actually the London Olympic Stadium in 2012, the very first structure which ever given design for deconstruction possibility. Say, for an example, every one of these elements can be completely removed and refigured. So if they don't want this and then they don't have time to, the people will not come, and then rather than that particular stadium staying there for nothing, and then they will be using, and then I think they expected about 120,000 or so for the Olympics. So they had a one seating tier which can be removed after the Olympics, because other sports will not draw that many people at a given time. So these are the type of things the design for deconstruction is about. Um, I have given a little bit, you can read on what they have done, how they have recovered some of the materials, and so forth. So I think for today's session, what I have discussed is good enough for you guys to make sure that tomorrow's session will be a little bit engaged. As I said again, I'll send an email to you guys in short while, and then make sure type. Anybody can come, I don't mind. They can even come to both, but I'll be specifically discussing unit type A and B in the first session, C and D in the second session. If you carefully follow that, I think you can advance your project very fast, and then do a good job. So I'm really happy to take any questions from now, clarifications. Please free to raise your hand, and then I will mute you can switch on your speaker and then speak, and then I will try and answer that if I can. Any taker? Anybody want to do that? No takers? So we have almost 7 minutes to go. The question. Okay. This one. The question. By the way, anybody who can tell that what stage that you guys are in? Because I'm not sure how much that affect the this delay and coronavirus situation. Hello. Sorry, Sik. What I meant was how many weeks that you all have started. When did you start actually the semester? Okay, now 3 weeks. Okay, thanks, man. So you're into 3 weeks now. Uh, so you had a we started our semester since 25. Okay, cool. So your apartment, sorry, your units are identified now, right? 100%. And then you start initial sketches, probably. How many people have a plan now? Anybody who has a decent plan? Yeah, excellent. Yeah, okay. Semester since 25. So initial sketches are there, internal. Okay, it's yeah. I mean that will be good. When you say sketches, uh, does that mean internal layout? Okay. So you haven't started framing your flow plate at the moment? Probably not. Yeah. Okay, good. I think tomorrow we can discuss a little bit, and then I understand. I didn't expect that to be started anyway. Uh, uh, Tomorrow's workshop will help then, because I will discuss because luckily, if you can think of, internal walls are non-load bearing walls, right? So what we can do is what we normally do is also we can have a blanket load for, say, for an example, partition walls, something like 1.5 kPa, an average value, so that you have the freedom, maybe a little bit conservatively safe, but you have, that is how the designers normally do anyway. So you can have it is independent of where you are going to put it, because you are allowing for ceilings and services, you'll be allowing about zero point 0.3, say for an example. Finishes, you'll be saying, oh, okay, I'll be having tiles or carpets or whatever. Depending on that, I'll be having some amount for the ceilings and services. And then for the partitions, we can think, okay, residential buildings. Say, for an example, in Australia, for residential buildings, we are using about 1.5 to 2 kPa for partitions. So, but the partition walls are not load bearing, non-load bearing. Only thing it bears is its own self weight. So the slabs and the beams, using beams Slab is spanning between beams or directly spanning, the beams are spanning between shear walls. So which means that your you can actually have the flexibility to position your interior walls because they are lightweight partition walls. However, if any part of your house is the having a common boundary with the next unit people, then there you have to have a solid wall because of the privacy. So you can actually start framing uh, the, the flow system to accommodate that, except the fact that you have situation where one side of there's a common wall between two units, common wall use two units. If it is a shear wall, it's a concrete wall, you don't have to worry. But if it is having a large gap or something like that, then we have to make sure that it is acoustically, which means noise transmission is of a different quality. So we can think about some uh, solid wall there, like blockwork or hebel blockwork also. Or you can even get a little bit thicker wall, lightweight wall, but with more uh, plaster boards so that the noise can be minimized between two houses. All right, guys. We will then discuss tomorrow how we proceed with our work further. It is pretty much, it is not necessarily like a lecture, but I will put type A and type B, and I will also let, if you are happy, type A guys, if you wanted to share your plan or something, get a feedback. If you don't like to do it in front of the class, everybody see, what you can do is um, send me in an email or something. I will quickly have a look and then give you some ideas, or um, I can check if you want to do it. But otherwise, you can, if you're okay to upload from your end, I can give you permission to do that, and then we can discuss that as well. Okay, guys. So we'll close the day today. Thank you very much for carefully staying with us and then listening. Um, I'll see you guys. I think I said, can somebody tell me when the morning session starts? Yeah, tomorrow, 9:30. Okay, yeah, that's right. Yes, of course, I will. I will. So I will. I will try and do that. Yeah. Yes, of course. Yes, of course. So it is to be, I think, 11:30 here. Yes. Yes, it definitely. Hong Kong time. All right. Take care, guys. I'll sign off now. Bye. Bye, everybody. Thank you. Thank you, Sean.